One of the key assumptions of the ordered logit that I really want to touch on right now is the proportional odds assumption. And really all that's saying is that when we are shifting from one outcome category to the next, that the relationships of our betas are in the same direction, which I think makes sense, right? We want to make sure that moving from one category to another category has the same relationship with that covariate, right? We want to make sure that the relationship is essentially constantly increasing or constantly decreasing as we move from category to category. And we call this either the proportional odds assumption or the parallel regression assumption. So again, you can imagine, and this is exactly what we're going to do, is if we ran a regression where we had just a logit, where the outcome was the baseline, let's say category J, moving from J to J plus 1. So we just have a binary outcome, and then we do it again for J plus 1 and compare it to J plus 2. Again, what we should find is that there should be the same relationship for a coefficient across each of these separate regressions. So what I'm doing here is I'm literally running a different regression where for each of the potential outcome categories we have, if it was not concerned at all, it would be 1, and if it was any of the other ones, it would be 0. Then for the next one would go, if it was not so concerned, it would be 1, and any of the other ones, it would be 0, and so forth. Now, what we find is that it doesn't really seem like the parallel odds assumption is holding, which may indicate that these are technically not ordered categories, or potentially that we have the wrong categories. A simpler way of modeling this that we could try, I'm not going to do, but you could potentially, is just do concerned versus not concerned. So we would collapse the very concerned and somewhat concerned, and concerned, not concerned at all, and not so concerned together into two different categories.